Well, if you recall, previously we stated that two figures are similar if all matching angles are equal and all matching sides of the same ratio, yeah? Because angle kind of limits its overall shape, and the sides limits its proportionality and size. Well, in similar triangles, then there will be 6 conditions to be considered. So 3 angles and 3 sides, which is remarkably similar to what we had with congruence, where we have 3 matching angles have to be the same and 3 matching sides have to be the same. But its only difference is that the sides don't have to be the same, but they just have to be in the same ratio. And it's almost exactly the same as, well, in congruence, not all 6 conditions have to be at all times. So in here, you don't have to find all 3 angles and all 3 sides. You just have to, in most cases, you just have to find 3 of them. So these lead to the tests for similarity. So in this case, similarity, 3 conditions for each test. So let's go through them all. The first one is when all sides are of the same ratio. Okay, so let's say 2 triangles. Yeah, let's call this side A, B, C. And this one, let's say X, Y, Z. So notice you have used lower cases as the sides. Yeah, remember in this subject, mostly capital letters are for angles and lowercase are for sides. So we have here, so all sides of the same ratio. What does that mean? So it means, okay, all matching sides of the same ratio. So A matches with X, so let's say X over A has to equal to Y over B, has to equal to Z over C. So in this one, we call it side, 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 which is very similar to congruence. Yeah? And next one is 2 sides of the same ratio included angle. So recall that this is extremely similar to congruence once again. So if you have 2 shapes, 2 triangles, let's say we have A, B, C, and another one D, E, F. What it means is that, say, this angle here, if we say DE over AB equals to DF over AC, and angle BAC equals to angle EDF. In this case, they are also considered similar. And this is, of course, it's called side angle side condition. Yeah. Now, next one, once again, it's very similar to the congruence. We have in right angle triangles, hypotenuse plus one shorter sides of same ratio, and so basically all this means is that if we have two right angle triangles, let's call them, say, EFG and RST. All it means is that FEG equals to SRT, so right angle, and ST over FG equals, if you can identify these are right angle, then everything's set, equals to either correction SR over FE, or alternatively RT over EG. So once you have the ratio between the two hypotenuse, either one of these two sides will be fine. It all depends on the condition you have been given. Now, finally, if we have two triangles, if all matching angles are equal, so let's say two triangles, once again, two triangles, let's say M and O, and another one Q, P, R. Oh, by the way, the shorthand for the previous one is, once again, still RHS. Now, if you will look at our example here, all we have to say is angle NMO equals to angle PQR, angle MNO equals to angle QPR, and angle NOM equals to angle PRQ. If this condition, if all three are satisfied, so if all the matching angles are equal, then we can say that these two triangles are similar. And because they don't have to be the same size, so we do not need an extra side to restrain the size of it. So this is actually, the shorthand is equiangular. Equiangular. But some people write AA. Well, let's go through a few examples. So first one, a triangle. Yeah. Right angle triangle, KLM. One side is 5, one side is 12. And the second one, PYE. One side is 7.5, the other side is 18. So it's quite obvious. We have the right angle, hypotenuse, and a shorter side. So if it works, it will have to be RHS. Now, all we have to do is just to verify that. So let's go through the right angle first. So angle MKL is the same as angle EPY equals to 90 degrees. Yeah, because it's obviously given to you. Now let's check the hypotenuse. Yeah, the two hypotenuse, whatever the plural of hypotenuse is. It's customary to have the right one on top, but it doesn't really matter. So EY over ML, so equals to 18, yeah, EY over ML, 12. And obviously this is 3 over 2, yeah, or 1.5 U bond, doesn't really matter. This is the ratio between the two hypotenuse. Now let's try the shorter sides, which is PY over KL. So it's 7.5 and 5. Just like magic, it works out. Once again, 1.5. So now we have a hypotenuse and a side. Okay, so we can say RHS. 3 conditions are satisfied. So we write, therefore, triangle MKL equals to triangle it's similar, so 3 vertical lines similar to triangle EPY. Okay, let's try something slightly different. Now we have a triangle BDF. Okay, let's close the corner. 12, 8, and 15. A second triangle. (11.25). Okay, X, W, U. 9 and 6. The thing with this question is that the two triangles are oriented quite differently, so we need to be careful with the matching sides. So we have WX, so the long side matches up with the longest side. So WX over BF. So it's 11.25 over 15, which conveniently equals to 3 over 4. And the next one. So we look at second longest side. WU over BD. So WU over BD. They're both the second shortest in their respective triangles. Equals to 9 over 12. Once again, 3 over 4. And finally, the shortest sides, XU and DF. Equals to 6 over 8. So XU over DF, which again 3 over 4. So we have one side, and third side. And therefore, triangle BDF is similar to triangle WXU because of side. Oh, almost forgot. The last one meant to be RHS. Always stated the reason. Yep.